Alright, I wanted to present something other than the two-way table, but this tree diagram, and it just kind of depends on the information, how it's presented. But here I have some, we just dealt with this part, but I'm kind of shrinking that down. You probably can't even read it. But this 50% of tests administered were the new saliva test. Okay, so I'm going to make this first branch saliva test versus the standard test. So I've got the new saliva test. And 50% of the time they're using that. And then here's the standard test. And that's 0.5 as well, just by the complement rule. Saliva tests have 88% accuracy. So when we use the saliva test, it is accurate, or it comes up with a true and accurate diagnosis on the length of concussion. It's not like a false positive or that kind of thing that we talked about earlier. But but then it's inaccurate, or I guess false, 0.12, just doing a little complement, 1 minus the 0.88, 0.12. The standard test is used half the time, and they only have a 68% accuracy rate. So accurate or true to it, and then it's inaccurate or false. I guess I could use inaccurate and accurate, but 0.34 over here. And so we have 4 branches coming off this tree diagram, and the math should be pretty reasonable because half of 88 is 0.44, and you might recall 0.44 was over here in our little two-way table right there. Alright, so these numbers that are coming out here, half of the 0.12 is 0.06, and that 0.06 was sitting right here in this. So just a different perspective. Half the standard are true, and then so 0.34 is the result of getting to this branch, and that came from over here in this corner, and then that last corner was the 0.16, and then things all added up to 0.5, 0.5, 0.22, 0.78, and then 1.0 over here. And so we have the half of the 34, which was 0.17. Did I do that right? I feel like I did something wrong. Half of the 34, 15, 16, 17, 17, yeah, what am I doing? 34. I feel like I messed something up. Oh, I took a quick break and I realized my mistake. You probably saw it. This was 0.32, and this came out to 0.16. I did my little math a little funny over there. Anyway, 0.16, and sure enough, that was over there. So all of these numbers at the end add up the total of 1.0. And then we can answer questions like this. If a test is inaccurate, so where is inaccurate? If it's inactive or accurate, or given that it's inaccurate. So we've got saliva tests. Once in a while they're inaccurate, so that's that group. And then we've got standard tests, but once in a while they're inaccurate, so it's this group. So given, or if a test is inaccurate, so we're looking at those two combined. So that is my denominator. So 0.06 plus that 0.16 becomes, so if they're inaccurate, what's the probability that it's the new saliva test? So it was the 0.06 over those two together. So 0.06 divided by 0.22. 0.06 divided by the 0.22, and it comes out to, the answer is 0.27 repeating. It's about 27% of the time. When it's inaccurate, then it's going to be the new saliva test. But conversely, then if it's inaccurate, probability that it's going to be the standard test, well, that's the 73%, the complement of that. So I hope that helped a little bit with the tree diagram and how you can use that